Well, hello everyone. Hey, Art. You are number one on the YouTube. Actually, you're number one. We're waiting for our friends on Instagram to check in. There's Chris Demo, number one on the Instagram. How are you? Happy Sunday. The sound is robotic. Uh-oh. Hey, Art, can you corroborate that? I'm looking for a corroboration on that. H. Bolivera, welcome. Can somebody give me a sound check both on Instagram and on YouTube, please? Sound is fine on Instagram. All right, let me try switching microphones and see what happens. It's always something. Can I change my mic here? No. Might have to unplug it and plug it in. Can I get some more feedback? Sound is crazy. Okay. Hold on. We're going to try something here. If only I knew what it was. Hold on. I'll tell you what, YouTube. I'm going to... I don't know what I'm going to do here. It's never simple. Phooey. Stand by. Hello, testing. 1, 2, 3. Is that any better on the YouTube? Welcome to Kinetic Imprecision. Same. Okay. I'm going to try to change the input, the audio input on the live. And I don't know how. All right. YouTube, I'm going to restart the stream. I don't know if it's going to work. Yeah, once you start the stream, there's no way to fix it. Sorry, guys. Let me see if I can restart the stream on YouTube. Instagram, just stand by. Isn't this great? Makes for good video. Trying this one more time. Okay. We're live again on YouTube. I hope our guys find us. It's always something. Well, hi everyone. Sorry for the sorry for the technical difficulties. We will put it on the checklist to fix that. But Instagram's working. So hi. Warren, welcome aboard. John, nice to see you. Wes. Hey guys. So I hope the other guys find the new stream. What a pain in the neck. How is everyone? Happy Sunday. It's the day before Independence Day here in these States United. Mr. Blodgett is here. Welcome aboard. Job Shop Machining, welcome. Hey, John, I hope you're getting a little outside time. Yeah, Warren, if you're home, just go to the Kinetic Precision channel. It should show that we're live right now. I'm kind of bummed that broke. So, let's see. Hassan, welcome. I was out this morning power washing. So it's pretty warm here today. It's not crazy warm. But I was out power washing and working up a sweat and getting wet and getting dirty, and ended it just in time to run down here and get us going. Awesome, Warren. Dot, welcome. So I posted that we're going to talk today about stiffness, hardness, and density. And we are. And that came out of the I was listening to something on podcasts, and I heard some folks talking about basically confusing hardness and stiffness. And I thought, gee, we should talk about that. So that's on the agenda today. And maybe it will shed some light on dealing with things where you want a component or a fixture to be stiffer, but so you can make it out of hardenable steel or whatever. So I want to get into that a little deeper. Welcome. Yeah, we got a bunch of people coming in. I'm terribly sorry about the YouTube issue. I think there's no way to technically troubleshoot it once it starts. But we are live on YouTube right now. Well, this is both about pie and metal. So, actually, it's about everything. Or, as we say, ¿por qué no los dos? Nick is here. Welcome. I hope everybody's having a good day today. And, tomorrow is Independence Day, and in which we celebrate our independence from Britain and the signing of the Declaration of Independence in 1776. Go to the channel, Mr. Blodgett, and you should see that we're streaming live. If you go to the channel, I'm not going to troubleshoot it right now, so I think we're just going to run with it. I'm really bummed because we made some significant improvements here in terms of networking from last time, and I really want to test it out. So see if you could find the stream by first going to the Kinetic Precision channel on YouTube, and it should say something about us being live right now. We'll figure it out. But there's another country today fighting for its independence, and there's some serious parallels here. So let's spend a few minutes this weekend and give them a thought as well. There's a lot of parallels. And of course, I'm talking about Ukraine and our friends there. It's just a mess. So let's think about them a little bit and see what we could do for them. So, yeah, this week in the shop was nothing major. I'm looking at Mr. Blodgett. Yeah, we are live on YouTube right now. I can't believe you can't find it by going to the channel. Low quality DS memes, welcome. Anyway, so not a lot of crazy shop work today. Shipped a bunch of product, and that was exciting. And then we got an order. I think we have one order on the books that I have to fill this weekend, but we have everything in stock. And that's going to Norway. So if you're watching, we'll get it out to you. Let's see. So we'll get into our topic, I guess. And well, first I'll give you a couple other updates. First of all, I worked with our graphic artist, and we have new stickers coming out. I will post about them when I have them in hand, and they're able to ship. I got two guys that sent me stickers. They want stickers, and they've been waiting on stickers. So we've got 4 new stickers coming out, and those will go into a pack, and then we will make that available. So that's one piece of news. John is excited. So stickers are coming. And my consulting graphic artist was very happy to help us and happy to submit me an invoice, which is paid, by the way. Pay the invoice. We're good. And I was actually, this is a sticker that happens to be sitting around here from GLG Knife Works, who is in the channel today. And it's one of the holographic stickers. And we have one holographic sticker coming out. I won't spoil the surprise, but yeah, I'm surrounded by stickers in this particular location. Oh yeah, of course I showed this one last week. I'm going to be making a sticker board that I could hang and move around. Yeah, it is shiny. Hey Chuck, welcome aboard. I was just watching you last night. 360 Machine Shop, welcome. Yeah, if you're not following Chuck Bomarito on YouTube, you should. He just did a cool video. And I'll tell you another cool video that came out. I do need your sticker. So Chuck, stand by when I get the other stickers. We'll do a big exchange. We'll figure out how to do it. But yes, I need your sticker. And Tuck Garage, I want a sticker. Yes. I didn't mean to start this right now. Once I have the new stickers in hand and I make some packs, I will put the word out and we will do the great sticker exchange. I hope Adam the Machinist checks in. John at GLG Knife Works says, very cool. It's like a cinnamon bun factory in here, sticky and sweet. Yeah, I'm sure it's both. Yeah, I'm on shower number 1 for the day. So yesterday I was doing my duty, and I was on the YouTube, and I was watching the usual gang, and we shall talk. And I watched Adam the Machinist's video. Now, it was a fantastic video, and you should go check it out. Adam is just a great tool maker, and I really enjoy what he did. Almost. Welcome aboard. You're almost here. So if you're from the old days and you remember R.J. Newbold and the Newbold Indexer, you won't want to miss this video that Adam the Machinist just put up on YouTube. So go check out his channel. Really cool stuff. So I'll give you another brief update on the mower. the Moore rotary table, which until we're mobile again with the camera in the shop, which I can't do yet because of the dual streams, I can't really show you what's going on. His differential gear spacing video, that is correct. But the Moore is happy. I haven't done any work with it yet, but I did get some correspondence that furthered the story of the Moore, and it cemented the connection from Moore to MIT. I showed you guys the emails I got from Moore, and also from MIT to Draper Labs to Brothers Machinery to a gentleman who shall not be named, to our friend Steam Sculpture on Instagram, and finally to me. So I have started putting together a document with all the information. That document, a PDF of that, it's a PowerPoint. A PDF of that is up in my links. So if you're interested in that whole story, when we're all done today, you can go to pfg.gg/links, and you'll see the link to that PDF document, and you can share in on the fun. There's a few more traces or a few more paths I'm tracing, and that might shed some light on more specifics about what that tool did. Somebody sent me this week an interesting link to Sperry, to a program that was at Sperry Gyroscope, and they were using a high precision rotary table to test accelerometers by rotating the accelerometer highly precisely and taking data. And that's pretty much what the program that the Moore table came out of was doing. They were working on accelerometers, so it's possible that it was involved with that type of work, and we're pretty sure that that was for the Apollo program. So we have some new folks showing up. Welcome aboard. Sorry about YouTube not working, but it's not, and I don't have time to chase it. So I'll play with it later. If you guys are around later and you see me popping up on YouTube and doing some testing, jump in and help me with some tests. So that's the Moore story. The document is up on links, and you can go grab it, pfg.gg/links, and it's in there. So I had another really cool phone call, I think it was yesterday, with Adam Brunette from MHM Machining. He's got a job shop. He's making some products for customers, and we started talking about essentially an MRP system for small shops. And you know, I have a small shop. Adam has a small shop. I sell products. He sells products. I have, I don't know, a dozen SKUs, a dozen specific things that I make that go into inventory and then I sell. And his is about 20. So it's all about the same. And we started talking about how to keep organized and how to keep all the ducks in a row. And my system has evolved over time, but right now I'm really happy with it. And it consists of a spreadsheet. And the funny thing is that John Saunders of Saunders Machine Works, he also talked about how he ran things by spreadsheet for quite a while until they finally got their MRP system up and running. So my spreadsheet is on, I have a disk server here, a Synology, and Synology supports, I don't know the name of the software package, but it supports like Google Sheets, except it's hosted locally. So I could go bring that spreadsheet up from anywhere. I could bring it up on this computer here. I could bring it up on the computer in the office. It's all the same spreadsheet. And that spreadsheet runs my entire PFG stone and balancing rings and all the things that I sell from here. It runs that whole business. But mostly it's the PFG stones that has the most churn. and requires, because it's effectively made to order. So if I don't get any orders in a week, I'm probably not doing any production in a week. And I had to figure out at each stage of production, from raw materials to ready to ship, I had to figure out what were the safety stock levels, what level of inventory I was comfortable with. And if you follow the principles of lean, if you follow Jay Pearson of Pearson Work Holding, if you follow John Saunders, if you follow John Grimsmo, we've all studied and taken some or all of, well, nobody's taken all, but of the lean concept that that is out there that Toyota started. And I like Pearson's approach because it is a distillation of the important chunks for a business his size, and it's a simplification, and I like it a lot. But the important thing is you don't overproduce. You make enough production to meet the demand, and that's it. With a caveat that you have to have some inventory. So that's what we do here. I have a stock level of ready to ship, and then for the products that I ship a lot of, it's a bigger number than the products I only ship a couple of every now and then. For example, we shipped a set of 8-inch stones last week, and we don't sell many sets of 8-inch stones. They're very big, they're 8 inches, and they're more expensive. So it's a very low volume item, but the guys that are working on very big machines or very big precision surfaces, they appreciate the longer stones. So that has a stock level or safety stock of 1. So basically all the time I want 1 set ready to ship. So I've just shipped that one. So the spreadsheet right now is saying to me, you need to go make 8-inch stones to refill that one. So the way to think about this, even if you're just using a spreadsheet, is you think about, how much time do I want to be able to go and be able to ship product without making anything? And that number for me might be, this isn't exactly accurate, but let's say it's 2 weeks or 10 days or whatever. So now that's what sets my safety stock and no more. So it's a real temptation, especially when we have machines that take a lot of setup, and I want to talk about setup in a minute, but if we have machines that take an awful lot of setup effort, once we get the machine set up, the natural tendency is to want to produce. And who cares? We have raw material. Instead of making 20, let's make 100. And you have to make that decision very carefully, because you have process improvements, you have product improvements that change the design of the product. If you have a whole bunch in inventory, you're going to be throwing some of that out, or you're going to be selling inferior product for a while until you start getting the new product in line. Both of those are, it's a decision. You have to sort it out. So our philosophy is keep it small, so you don't have a lot. The other thing about overproduction, which is one of the wastes in lean, is you have to have a place to store the product that you just overproduced. And another thing we tend to not think about, especially as home shop machinists, is the cost of storage. I started to think about every square foot is $1 a month. It's not kind of arbitrary, but if I have to, if I make 20 extra things and I need a square foot in the shop to store them, well, there's $1 a month or whatever that is now going out the door for as long as that storage is there. So you have to put a dollar value on storage, and that's another thing that affects that decision of how much you produce. But I'm super happy with the spreadsheet now. So I have a safety stock for raw materials. In my case, when I buy stones from Norton, those are raw materials. So I have a safety stock level of how many of those are there. The spreadsheet captures that. I have the capability of tracking work in progress, although all my work gets done in one day during production. I usually don't use that. And then I'm tracking the other raw materials like trays. So I don't have a tray to show you. Oh yeah, I do. I should be waving around a set of PFG stones while I do this. So the raw material is the stones as they come from Norton in the cardboard box. I make the trays, so I have on the spreadsheet a column for how many trays I have in the drawer. This seems trivial, but it's not. I should, but I don't have a place for how many rolls of filament do I have on the shelf. I use a Kanban system for that. I'll explain that in a minute. I never want to see less than 3 rolls on the shelf. So when I hit 3 rolls, I place an order, okay? So all of those things are on the spreadsheet. So what happens is I'll come into the shop and I'll do a quick inventory because sometimes things get crazy. And I'll make sure my spreadsheet matches the reality, okay? As soon as the spreadsheet matches the reality, there's 3 major sections on the spreadsheet. One is go order more stones. The other one is go 3D print these plastic parts like trays and lids. And then the last one is go make these stones. And now you're just doing what the spreadsheet tells you to do. And my job is to drive those numbers to 0. So I'm not thinking about, oh, I have to run and build and make this thing for this order so I can get it out the door, which is a very high pressure, uncomfortable thing. It's just, I produce these things and drive these spreadsheet columns to 0. Because if I do that, then I change hats and the shipping guy comes in here and the shipping guy says, oh, look, I have an order to fill. And by the way, I literally do this. I finish production, I clean up, I clean the bench where I do shipping, and then I start shipping. And then you pick, you package, you ship, and you put the labels. We have the label printer, and it goes out the door, and then everything's cool. So at the end of the day, I do a lot of my work on Sundays, right, on the weekend. At the end of the day, if you look at that spreadsheet and all the things are 0, job done. And then you take risks, like some of them might not be 0, but you also know that it's not an emergency. It's a lot easier to keep track of things. So that's a brief overview of how I use a spreadsheet for my MRP system here. It's very simple. You don't have to buy any special software. You don't have to pay any money for special services. We're small shops. We could handle it. And my whole PFG stone business is running on that spreadsheet. So before we change topics, does anybody have any questions about that sort of stuff and how to keep track of how to keep track of orders and inventory and in-process work in a small shop? Come up with a question while I have a sip. By the way, as we're waiting for some questions to roll in, absolutely nothing is happening on YouTube here. Kind of bummed. So what'll happen, by the way, is I will do my usual putting this Instagram Live onto YouTube. So none of this material will get lost. And then I will keep beating on the YouTube stuff. Oh, I should say, if you at the bottom of your screen, if you have a little question button, that's the best way to submit a question. Otherwise, put it in chat. and we will figure it out. Mr. Blodgett says, do you also use a bookkeeping software, and do they integrate? Yes? No. Okay, so I'm going to put two questions together. Tuck Garage says, how do you connect sales with delivery/shipping addresses? Okay, so let me widen the picture for you. For bookkeeping, I use QuickBooks, and it is not connected to everything else I'm going to tell you about. So there's no integration. So QuickBooks is my bookkeeping software, totally separate. But our store is on Squarespace, and we use ShipStation for our shipping software. So the store that takes your orders and gives you the nice website and helps you calculate postage and does all that stuff, that's all in Squarespace. Other people use Shopify. I don't, but I respect it. John Saunders likes Shopify, and I almost took a hard look at it because of some stuff that happened, but I didn't. So I'm happy with how Squarespace works. Now, Squarespace does integrate with ShipStation. So just to clarify, I pay Squarespace every month. They host the website. They have the commerce. So I have the commerce level of subscription, and that's Squarespace. And then it integrates with ShipStation. ShipStation is another monthly fee, but ShipStation does all the shipping. So I usually don't look at Squarespace much at all. The orders come into Squarespace. It automatically, hands off, it comes into ShipStation. And when I go to fill orders, I'm opening ShipStation on my computer. Let me make sure I'm answering all the questions. So bookkeeping, okay, so I answered that. How do you connect sales with delivery shipping addresses? That's ShipStation. And I see there's a question in the queue. Bart, I'm going to get back to you. Wes says, oh, Wes, I'll get back to that in a minute. Let me finish this non-technical PFG stone discussion, and then we'll talk about that. Bart says, would a system also be useful for small job shop work? I don't have production orders or inventory. No, there's an expense associated with ShipStation, and there's an expense associated with an e-commerce store like Squarespace provides. And if your job shop, your bookkeeping software, I think, is pretty important. I don't think anything I'm talking about directly relates to job shop work. So I think the answer is no. And I believe in keep it simple. Bookkeeping is very important. We use QuickBooks. QuickBooks, I think, will also do, orders and invoicing and all that kind of stuff. I know it does invoicing, but I think it could handle a lot of stuff for job shop work. So I think I answered that question. Okay, so we got some questions coming in on PFG stones. Any last questions on managing workflow, inventory, orders, shipping? I didn't expect to talk about that today, but I did want to talk about the spreadsheet because I guess the punchline here with respect to the spreadsheet is you don't have to go out and spend thousands of dollars on software if you have 20 products to ship. Okay. I'm going to transition into let's answer some of these questions. I'm looking at my notes here. We talked about this. Check, check, and check. Okay, so let's address some of these questions that are coming in on PFG stones. Wes asks, would there be an advantage for natural PFG stones like an Arkansas stone? So things like Arkansas stones, which are natural stones, are very dense. They don't have a lot of pores. When you use a PFG stone and you cut a burr, which is the same as, taking down a high spot or any of those terms you want to use, where does the material go? Especially if you're not using it diagnostically, if you're literally improving a surface, you're going to remove some material until that stops. Where does that material go? So that material needs a place to go. If it doesn't have a place to go, we get a condition that we call deflagrate. Good question. I'll address that. He says, can you show a pro forma version of your spreadsheet? I could, but I can't do it right now because I don't have one that isn't full of proprietary information. So I'll see if I can. I'll do that for next time. So taking homework, pro forma spreadsheet. Got it. So the material on the stone needs a place to go. If you don't have a place to go, we get a condition that we call loading up. Okay? Or if you have so much material compared to where it has to go, you have loading up, and that's no good. And then you have to clean your stone in increasing order of solving the problem. You have to condition your stone one on the other, right? So that's conditioning your stone, right? And that helps to get rid of stuff that isn't part of being flat. The second thing you may have to do is clean the stone. We've talked about ultrasonic cleaning, a brush and Dawn dishwasher detergent cleaning, alcohol cleaning, WD-40 on the corrugated cardboard cleaning. All those things are cool, and they help get that schmutz out of the pores and have it go away. But what happens when you have like almost no pores? You have almost no place for it to go. I worry about that. If you're doing super uber pooper fine work, yes, there could be. Let me say this very carefully, so there's no confusion. If you're doing very fine work, yes, you can make a precision ground flat stone and use it. It does not say that it's going to work better than a stone that does have pores, okay, and a place for the stuff to go. It's kind of cool if you just look at it, you see the pores. Like, okay, that it all makes sense. That's where the stuff is going to go. Then you have to ask, like some of the Arkansas stones I've seen, I guess they're called soft Arkansas stones. They're quite soft, which is leading into our major technical topic for today. So is there an advantage? Let's just wrap this up. Is there an advantage? No. Have I ever thought about it and tried it? Yeah, I got a drawer right here. I got Arkansas stones hard, Arkansas stones soft. I've played with other stone materials. Oh, hey Marv, welcome aboard. Oh, Marv's here. Now I gotta, when we start talking about hardness and stiffness, Marv is gonna be on my case about getting it right. So excellent. Let's see. There was another good question here. Have you ever tried the ruby stones, like the synthetic Degauss yeah. So ruby stones are, I have not had them in my hands. But let me tell you something about the word ruby. If it's truly rubies, like, right, it's aluminum oxide. The crystal on my good watch upstairs is sapphire. Aluminum oxide. These PFG stones are made out of aluminum oxide. So the material which is doing the work in all those cases is aluminum oxide. It's how it's held together that makes the major characteristics of the material. So we'll leave it at that for the moment. Okay, questions are coming in fast. Bart says, do you use the coarse or the fine side of the stones? Yes. If I'm expecting a lot of schmutz to come off when I'm stoning, I like to use the coarse side for the same reason. But if I'm going to do something where if it's a diagnostic pass with the stones where I'm feeling for scratches and I want to know what's going on, I'll use the fine side. Like when I'm on my chuck on the grinder, a lot of times I'll go to the fine side because I know it's not going to be, there's not a lot of material there, but I'll just use the fine side. So I use both. Let's see. Tuck, I thought I hit your question. Here it is. Could you add grooves to turn it into a, quote, lap of sorts with the Arkansas stones? Kind of like a high grit. Yes. Stay tuned. Stay tuned. You'll see a lot of stones that are serrated, which is kind of what you're talking about. And serrations are a way to provide a place for the schmutz to go. So that is a thing. It's potentially useful. And I am looking into that. So we'll talk about that more later. Here's a good question. Nick asks, while we're on PFG, do you have experience with PFG stones on titanium, grade 2, and or duplex stainless? He goes on to say, I have a project involving these metals at work. Okay. Do I have experience with? No. I've used the stones on stainless, but I honestly don't know what duplex stainless is. And I have not used it on titanium because I just haven't had a call for it. I'll tell you who has used it on titanium is I think John Grimsmo might have used it on titanium more than anybody else on the planet. So I'll have to ask him about that. It will work on all those materials. Just remember, use it for what it's designed for. You're not going to bevel a corner with a PFG stone. Some have tried, but yeah, that's the short answer to that question. I answered that question. I think we're good. So let's talk a little bit about what prompted my the title of today's live, which was stiffness versus hardness and density. So let me start with density because density is pretty easy. Density is for a given volume of material, how much mass is there? And if you think about aluminum, if I showed you this, this piece of aluminum and I said, this is aluminum, you guys are all, you kind of know how heavy you expect this thing to be. And of course we can go weigh this. I'm not going to, but this is a low density metal. There are other materials which are low density. You can imagine, a piece of syntactic foam, right? As a material, it's low density, lower than this. And then you think of a piece of steel. Here's some stainless steel. This is 316 stainless. It's exactly the same size as the aluminum, but it's heavier. It's got a lot more mass. I bet you know where we're going with this, right? reach into my magic box. And no, this is tungsten. And just holding this here, I mean, this is amazingly heavy. If you have not like played with a chunk of tungsten just in the presence of other things, it's pretty incredible. So these three guys are the same exact size, but they're different materials and they have different densities. How does that compare to their hardness? Not at all, okay? If you dig down into the physics, you could probably make the argument that there's a connection there. But as far as we're concerned, it doesn't tell us anything. So here's a really nice visual demo. Let's see if I can make this work. Can I make that work? Let's see. This will work. Okay, so here's our piece of aluminum. Oops. No, let's start with our piece of tungsten. So here's a piece of tungsten. The YouTube, yeah, I don't think we're going to be using that anyway. So there's a piece of tungsten, and that weighs a certain amount. Now here's a piece of steel that weighs the same amount as that piece of tungsten. Okay, so if you look at that, it's more than twice the difference in density. This is basically a real bar graph. Tungsten, stainless steel. Now you could say, well, wait a minute, that's stainless steel 316. That's different density than 1215 steel. Microscopic differences, like almost impossible to detect unless you're really serious about it. So let's just say that steel is steel, and that's a theme you're going to hear again later. So tungsten, steel, same weight. All right? What do you think the aluminum looks like? Aluminum. So all of these have the same diameter. All of these have the same weight. 6061 aluminum. And by the way, aluminum is aluminum also. Again, teeny variations, but basically aluminum is the same. Aluminum, steel is steel, tungsten. Now this tungsten is not 100% tungsten. This is 90% tungsten, 6% nickel, 4% copper. It's also called tungaloy or hard metal, heavy metal, different brands. But it's tungsten with enough nickel and copper so that you could actually machine it. But it's still, 90% tungsten. So this is density. So this is a really good visual representation of density. And now if you think about machining this stuff, you guys are wincing at the thought of machining the tungsten alloy. Steel, you just got to use the right techniques and it's no problem. Aluminum, cakewalk, right? Easy peasy, lemon squeezy. There's some correlation there. If we put a similar thing of syntactic foam, it would be feet long, and that you could machine the foam with your pocket knife. So this is density. There's a relationship behind the curtain between density and stiffness and ultimately hardness, but just keep them separate in your mind. All right, so this is a fun visual demo. So the next thing I want to talk about is, and this was the big one, is the confusion between hardness and stiffness. So let's say, for the purposes of argument, that I take this piece of, here's a piece of steel, okay? This happens to be, well, let's just make believe. I'm not exactly sure if this is A2, but let's just say this is A2 tool steel, which it might be. And I go over to my hardness tester, and I go and I test it. Well, what does the hardness tester do? It puts a diamond in it, and it pushes it in with a certain amount of weight, and it measures how far it went. So it's a diamond penetrator. And then when you take the diamond away and you put it under the microscope, you see this little volcano, right, of displaced material. Displaced material. Very important. And the deeper that indentation went, the softer the material. So A2 tool steel annealed in its soft state is going to measure some hardness. Might even not quite be on the Rockwell scale, which starts at 20, Rockwell C20. You might have to go to the B scale. Now, I take this and I put it in a machine and I go to bend it. And I literally push on the rod and I bend the rod while the other side is being held. I push it and I bend it a little teeny bit, and I measure how much force it takes to move it a little teeny bit. And then it recovers because it was an elastic motion. Now I go off and I harden this piece of A2 tool steel. I send it over to the heat treater, I put it in the oven, I do all the magic stuff, and it comes back Rockwell 62 C62. Now I go back to my hardness tester. I stick my diamond on it, and I put the same amount of weight on my diamond, but it doesn't go in as far. It goes in a teeny tiny bit, which is measurable, and that teeny tiny bit that's small is now represents a high hardness because I'm trying to displace material. I'm making that little volcano. As I put my indenter in, it's pushing material away. And it doesn't want to do that anymore. So it's now harder. So isn't that better? So now I'm going to take this in my same clamp, and I come over here and I put that little tiny amount of force on it, and I make it move a tiny bit, and I bend it. What do we see? What's the result of that experiment? Think about it. That measurement is stiffness. It's related to Young's modulus, which is a fancy number that we assign to materials. That's stiffness. What happened after my heat treating? I want a couple of answers, and I'll give you my view of this. Mr. Blodgett says same. Okay. You all agree? Same bend, meaning the same amount of bend for the same amount of force, as long as we're keeping it small. Okay, so the answer is you are correct. The heat treating of this material did not change how stiff it is. So as long as here's a metal rod, okay? So as long as I am bending it so that I'm not yielding the material, which is another way of saying displacing material. If I'm not yielding the material, this can be soft, this can be hard, and it doesn't matter. And if it's steel, it's steel. And that would be the correct answer. So if I have a fixture and I'm holding parts and that fixture's bending, and I'm like, oh, I don't want that fixture to bend anymore, I'm going to send it out and I'm going to have it heat treated and it's going to come back harder. What did I do? Nothing. No, correct. Mr. Deflagrate says no effect on Young's modulus. That is correct. Okay? Now, if it's a fixture, I actually like getting it hardened. Here's why. It does reduce the scratches and the wear that you get in handling, in putting materials on it. My custom work holding that I make for my projects here in the shop, I frequently make it out of a tool steel and I harden it. And it's not because it makes it stiffer, it's because it makes it harder, which means it stands up to abrasion and it stands up to getting dinged in the process of production. It does not change the stiffness. So now let's take another little example here. We've got two materials. This is an aluminum rod, and this is a steel rod. Okay, and I'm the clamp, and if I push down on these guys like that, they're in their linear range of the material. I bend on them, they come back, right? Now watch this. You see? I exceeded the yield point of the aluminum when I made that bend, but not of the steel. So I have yielded the aluminum. I permanently yielded the aluminum. You could make the argument that this aluminum rod has a lower Young's modulus, but it has a lower yield point than the steel. Okay? Now, if I took another piece of steel and I hardened it, same material, let's say this was a piece of A2, this steel here, okay, and I hardened it and we did the same experiment, we'd get the same result in that the aluminum would yield first, the unhardened steel would yield second, and then the hardened steel would yield last. So if you have something that's bending, that's another case where a hardened material may be more appropriate. Okay? Now, get ready to have your mind blown. This is a thought experiment. We're going to take a rod, a long rod, okay? And we're going to have one made out of steel. Let's say it's a 10-foot rod, and one made out of aluminum. Okay? And my specifications are that these two rods weigh the same. So you bore out your steel rod and you make the hole in the steel rod bigger and bigger until the weight of the steel rod, which has the same OD as the aluminum rod, okay, the two weights are now the same. Are you following me? Hey, Adam, welcome aboard. So, Adam, we're talking about specific stiffness. That's what we're talking about. The title of this next example is specific stiffness. So we've got the aluminum rod and we've got the steel rod. The steel rod we've bored out until it's the same weight as the aluminum rod. Now, we put this in our test fixture and we measure the stiffness. Okay? What do I see? The aluminum rod versus the steel rod, same mass, same length, same diameter, except the steel rod has been bored out to make the mass. And I measure the stiffness. What do I see? Vote now. So the concept of stiffness for a given mass is called specific mass. Oh, Deflagrate, you're taking a risk here. Deflagrate says aluminum rod is stiffer than steel. Okay, let's see if anybody has a different opinion or the same opinion. Vote now. So if you're, I'm looking for my steel. Here it is. Oh, so Adam says the tube meaning the steel tube is stiffer. Is that what you meant? 360 says the steel stiffer. Tuck says the steel deflects less than the aluminum. It's pretty good. Okay, so here's the shocker. If we go to specific, it's called Specific Modulus. Yeah, which is another way of saying specific stiffness. The specific stiffness of steel, I had it here. Hang on. Here we go. Yeah, the specific stiffness of steel is about 25. The units are crazy, but it's meters squared per second squared, which, yeah. The specific stiffness of aluminum is 26. So the aluminum's specific stiffness, in other words, the stiffness per unit weight, is higher than steel by about 4%. I will point to the sky and challenge you to find an airplane flying around that's made out of steel. So the aluminum is stiffer per unit weight. Here's the weird thing. You ready for the weird thing? You know what else has the same specific stiffness as aluminum and greater than steel? Sitka spruce dry, which of course is a wood. Even higher at 33. I'm sorry, where is it? I lost it. So let's go. Tungsten carbide, right? Would you rather have a tungsten carbide boring bar or a steel boring bar? Everybody knows you'd rather have a tungsten carbide boring bar. Why? Because the specific stiffness of tungsten carbide is 34.5. So it's higher than both steel and aluminum, but more importantly, it's Young's modulus, its stiffness, not specific stiffness, its stiffness period, is 500, and compared to aluminum 69 and steel's, where'd my steel go? 200. So stiffness, we know it's more intuitive to us, but specific stiffness, we don't really grok. And aluminum has a higher specific stiffness than steel. And yeah, Mr. Deflagrate says the aluminum bicycle frame is stiffer than steel. It can be. It gets interesting, doesn't it? By the way, it's the exact conversation I was having with my wife. By the way, I recognize we're at the top of the hour. We'll wrap things up pretty quick, but we are over. Adam the Machinist says, Howard Hughes has joined the chat. Exactly. Why? Because we follow Stefan. Yeah. That's why we want all the tungsten things. So this is really cool, and I wanted to blow your mind a little bit about specific stiffness. So if you go to make your fixture out of aluminum, if you have to think of this correctly. If you use a kilogram of aluminum, you could argue that this is a messy statement. But if you use a kilogram of aluminum and a kilogram of steel, your aluminum is actually stiffer. If you design it right to use the stiffness, it will be stiffer. So if you want some amusing reading relating to what we're talking about, just go to your favorite textbook or Wikipedia and look up Specific Modulus, and it's sort of eye-opening. Okay, we're at the top of the hour. We can get into this. There's a couple other things I want to touch on really quickly that came up this week. We did that. So let's see. Hang on, I'm just looking for somebody's. Yeah, so Bart was rebuilding a grinder, and he showed in his Instagram story his success in improving the performance of this surface grinder, because he was we were talking about balancing wheels and dressing wheels, and we had some back and forth about balancing, and he was still getting these weird patterns. And I said, is it motor imbalance? I said, put your hand on the housing of the grinding wheel, and what do you feel? And he said, Nick says, oh, the specific stiffness of beryllium. I'll get back to this grinder in a second. Beryllium was in here, and it was pretty impressive. Yeah, the specific stiffness of beryllium is 155. Okay, steel, you may recall, is 25. Yeah, beryllium. Nick says aluminum bike frame may be stiffer, but it's also a different shape, right? They typically use bigger diameter tubes on an aluminum bike. Yes, this is where you have to consider everything. But they are making them out of aluminum. And I remember when the first aluminum bike frames came out. That's how old I am. And I've got in my basement a Dawes double blue made out of Reynolds 521. Great bike. So back to Bart's grinder. So Bart took the wheel and the hub off the grinder, put his fingers on the housing, and he still felt vibration. So where are we now? So he thought the spindle bearings were okay and didn't think it was that. So we concluded that it was probably a motor imbalance. So I said, pull the belt off and run the motor. So anyway, he dug into this thing and ran the motor and said, yeah, that's no good. Rebuilds the motor. You have to look at his channel on Instagram. Is it on your, I don't know if it's on your regular channel. Rebuilt the motor, reground the pulley. It was awesome. Using a bench grinder, sitting on the table. I don't know how he did it, but it was absolutely magnificent. He says it was 0.6 millimeters on runout. Welding the motor shaft straight. Not sure if it changed the density. Thank you. And it's all on Instagram. So anyway, Bart did the motor, did the pulley. I don't know if he replaced the belt. But anyway, put the thing back together, ground the same piece of steel with the same wheel. Perfecto. It looked awesome. So congratulations, Bart. I wanted to give you a shout out because that job was awesome. And you get a gold star from the Grinding Hall of Fame, which is in Indiana, by the way. I don't know if you knew that. It's 207, and who knew? Oh, and a new belt. And he says much better results. Awesome. What am I forgetting? I'm going to take a sip of water, and I think we're going to wrap this thing up so we can go enjoy our grilled meats. So if you like the, by the way, this density demo that I did was done for a high school class a while back. Oh, Orange Vice, Eric, welcome aboard. I am happy to see you here. And I don't think we've ever had anybody so famous take the award of last into the room before we shut down. But welcome, Eric. If you guys don't know, Eric is the owner of Orange Vice, which makes fine products and has a great story. And I followed you, Eric, from the earliest days, and I'm very impressed that you maintained your decorum while you went through difficulties way early on. You're awesome, dude, and a great product. So if you want to see a big grinder, Eric's shop has a big grinder. I think it's an Oka. Is it? No, I won't say that. Hey, Eric, who makes your great big honking grinder, which you may have more than one of at this point? I thought it might be an Okamoto. But to do the Orange Vice bases, I believe Eric got a big grinder, and it was pretty impressive. We'll see if he answers that question. Any other questions? Anything else we need to do? So for next week, I will take it as homework to see if I can get you a pro forma version of the spreadsheet. We'll see if the stickers are ready, and we'll show those off. There was another guy who was having some challenges. Who was it? With grinding, and I asked him about his wheel dress, and he got that right. So another day we'll talk about wheel dress. I was going to talk a little bit about it today, but I don't think we have time for that. All right, last chance for questions. We're going to shut it down. It's 10 minutes after the top of the hour. As we close today, I'll remind you to have a safe Independence Day, 4th of July, and enjoy it. Enjoy your family, and give a minute to think about our friends in Ukraine that are dealing with their independence, and they have a fight. So as we're having our hot dogs and we're remembering a fight, back in the 1700s, let's just remember them. All right, guys. Happy Sunday. Enjoy your family. Go do something in the shop and sweep up. And we'll catch you next week.